This is the video tutorial for pages 8, 9, and 10 in the homework packet. This is Unit 2, so this was Day 5 of class. And Day 5 of class was Thursday the 22nd for Red Day and Friday the 23rd for Blue Day. So what we did today was we talked about writing and balancing nuclear equations. So we looked at alpha, beta decay, because gamma doesn't have a mass. We learned that in class. But then especially neutron emission. But these three things, remembering that this is an alpha particle. That's what we learned in class. That's written on your periodic table. This is a beta particle, and this is a neutron. So an alpha particle has a mass of 4, remember that top number, mass number, and 2 protons, and it's helium. A beta particle has a mass of 0, and it has a -1 down here. So all that means is it's the opposite. The negative is also an opposite symbol, so opposite of a proton, because it's just a high-energy electron. Okay. So when we're writing and balancing equations, we have to get our top numbers to be equal. We can treat this arrow as an equal sign. So we're saying 232 for the top number equals 228 plus 4. And we have to make sure that's true. So we would say 228 plus 4, yes, it is 232. So this one's balanced on top. And we do the same thing on the bottom. 90 equals 88 plus 2. And sure enough, 88 plus 2 is 90. So it's a balanced nuclear reaction. We did a couple of these in class, so let's take a look at number 4 right now and at number 7. Okay. So number 4 down here, using the same process like we did in class, I've got 222 equals blank plus 4. So 222 equals x plus 4, effectively. And I'm trying to solve for x now. Okay? So what I'm going to do is I'm going to subtract 4 from both sides. Okay? And 222 minus 4 equals 218. Okay, so now that I have 218 as my answer for the top, I'm going to write that up here, 218. And I can do the same on the bottom. 86 equals x plus 2. So in order to solve for x, we're just doing simple algebra. We subtract 2 from both sides. That makes this cancel out. So x equals 86 minus 2, which would be 84. Now, I don't know what symbol I need until I come back over and I find 84 in the periodic table, and that's right down here, polonium, PO. So we can say PO. So it's 21884 PO, polonium. If radon undergoes decay, alpha decay, this is what will be left. Okay, my mass number comes down by 4, my atomic number comes down by 2. If I'm looking here at number 7, students always kind of struggle with this one because you've got a -1 here. But what I have on top is 138 equals x plus 0. So what plus 0 equals 38? 138. It's still just 138. So remember, beta decay does not change the mass. The mass stays the same because this is just a high-energy electron for beta decay. And a beta particle is an electron. Electrons are so small they don't really affect the mass significantly. Now on the bottom, what I have is 53, and the arrow we're going to say equals blank, so x plus -1. Okay. So in order to get rid of -1, I need to add -1 to both sides, because -1 is canceled out by adding 1. So this would be 54. All right, you all see that now? So now what I have is 53 equals 54 plus -1, or 54 minus 1. So element 54 on the periodic table is right here, xenon, Xe. Okay, 54 plus -1 is 53. So now this is a balanced reaction. Okay, let's do number 10, because we did number 9 in class. If nitrogen 15 undergoes alpha decay, what will the reaction look like? Well, it tells you alpha decay. So one of these two particles at the end is going to be an alpha particle. And you can always check your periodic table, which you'll have on your test, otherwise it's written up here. So one of these particles is going to be alpha, 42He, so it's alpha decay. You're going to do the same thing up here for beta decay. One of these is going to be a beta particle, which is right there. So in order for it to be alpha decay, 15 plus blank, or 15 equals blank plus 4. So 11 plus 4 equals 15. 7 equals blank plus 2. That'd be 5 plus 2 equals 7. So now this is true. And element 5 on the periodic table is boron. So 11 plus 4 equals 15. We're balanced. And 5 plus 2 equals 7. We're balanced there. That's how we're doing page 8. Page 9 is very, very similar, okay, which is fantastic news. There's an extra 2 steps. And let's look at number 7. Number 7 is neutron emission, which we haven't really looked at. Neutron emission is going to change the mass, but not the atomic number, okay? So for the top, I have 140 equals blank plus 1. So what number, when I add 1 to it, equals 140? 139. Okay, and if you need to write out the algebra and say 140 equals x plus 1, and then solve for x, you can do that. You can show your work. Otherwise, it might be fine to do it mentally. And then 62 equals blank plus 0 for the bottom. What number plus 0 still equals 62? Well, that would stay 62. Okay? And it's just SM right there. 62. Okay, and SM is samarium. So all that changes for neutron emission is my mass. My element stays the same because my atomic number didn't change. So it asks you as well to circle the particle used. So the particle here would be a neutron, and that's neutron emission. E-M-I-S-S-I-O-N, neutron emission. So for this one, you would circle it and say alpha decay, and then you would go ahead and do that. And alpha decay, and beta decay. All right. Number 11 then is asking us to do the opposite, which is kind of interesting. They give me this side, and they're asking you for what it started as. So now I have x equals 11 plus 0. Well, 11 plus 0 is 11. That's not so bad. And then I have x, because I don't know what my bottom number is, x equals 6 plus negative 1. So let's even just go ahead and stick that in the calculator. If I can get this to turn on. 6 plus negative 1 equals 5. Okay, so 5. And element 5 we'd look up, that's boron. And this is a beta particle, so I would write beta. It's a beta decay. Alright, I feel like once students get the hang of this, it's really straightforward and pretty easy. It's really simple algebra as soon as your brain clicks it. So hopefully that video tutorial helped it click. If not, come in for just maybe 5 minutes of one-on-one tutoring, either for Eagle's Nest or after school, and you can cruise through this stuff pretty quickly. Let's look at this last page then. This is how we finished up our notes today, was fission and fusion. So this again is going to be something you have to look at, the notes packet, before you can do this. So they ask you to put them in order from least penetrating to most penetrating. So you're going to look at your nuclear foldable from this from last class. And now they're asking you if this is a picture of fission or fusion. So I've got two separate things combining together. So two separate things melting together. So if you put, I don't know, a bunch of candy in your pocket and it melts together, okay, that's fusing together. So this would be fusion. That's because I'm combining two atoms or two particles into one larger atom. And that's what fusion is. We're combining atomic nuclei. This one, I'm starting with one big thing. I add a neutron to it, and it breaks into two still big things, but not as big, and that is nuclear fission. Okay? The fission of a nucleus is breaking apart of a nucleus. So I'd say I started with one big thing, and I ended up with two smaller, one big atom, I ended up with two smaller atoms. So now down here, number 4, combining of atomic nuclei. That's exactly what we wrote up here, combining the nuclei of atoms. Okay? So that would be fusion, right? Splitting an atomic nucleus into smaller ones. That's what we just did on number 3, fission. Okay? So make sure you're checking your notes for these ones. These are all fair game on a test for asking you questions. Number 12 is very similar to what we were doing up here. They just mentioned that it's also alpha decay. And we want you to explain your reasoning in 3 or more complete sentences. And I feel like students say, well, I can answer it in 3 words. Well, that's great. Now do it in 3 sentences. It's a lot more difficult. Okay, and that's what we're asking you to do. So I'm not going to write anything, but I'll talk to you about it. Is this an example of fission or fusion? Well, I would definitely say fission. I'm breaking apart a nucleus because I'm going from one nucleus into two smaller nuclei. You can also mention that alpha decay is always an example of fission. It doesn't matter what element it is. It doesn't matter that it's uranium-235. Any kind of alpha decay would be an example of fission. And another thing you could say to explain your reasoning is that the picture, right? You can describe the picture. I've got one big thing and two smaller things. You can talk about how uranium-235 is what powers nuclear power plants or nuclear bombs. We watch those videos in class as well. Number 13 down here at the bottom, explain the process of fusion and explain why we're unable to use fusion on Earth as a source of energy at this time with 3 or more complete sentences. Again, I'm going to talk it out. I'm not going to write it out. I expect you to still write it. But fusion is what's done on the suns. So we take 2 smaller atoms, like 2 hydrogen atoms, and we smash them together to make helium. That's how the stars are powered, especially our sun. It's doing hydrogen fusion. That's what fusion is. We're taking 2 small atoms like hydrogen, and we're combining them to make a larger atom like helium. Why can't we do it on Earth right now? Because it takes a very high temperature and a very high pressure. And so it's not a source of energy. It's like saying I'm going to invest $1,000 in order to make $1. That would be terrible. We would spend so much energy making the fusion that the energy we get back is useless. Okay? So it takes too much heat or energy to be efficient. In the future, if we can find a way to do cold fusion that doesn't require so much energy invested up front, so if I can invest 50 cents and then make $1, then that makes sense. But right now we have to invest $1,000 in order to make $1, or 1,000 units of energy in order to make 1 unit of energy. It's just not efficient. All right, that's everything that's covered on this upcoming exam. Please make sure your entire homework packet is complete, and we will be ready to work on that review packet and that take-home test. Thanks, y'all.